So was quickly optical isomers. You had optical isomers were basically you need a chiral carbon for that. ठीक है, what's a chiral carbon? So chiral carbon is your it's a carbon atom which is sp3 hybridized. That basically means that it's making four single bonds with four different groups. So carbon makes four single bonds with four different. So with four different. So with four different groups. sp3 hybridized means that the carbon will be tetrahedral and the angles will be 109.5 degrees. ठीक है, and optical isomers is what you'll have is you'll have two non-superimposable mirror images. So there's another name given to optical isomers, and that's enantiomers. And a mixture of enantiomers is known as a racemic or racemate mixture. So a mixture of enantiomers, that one is known as a that one is known as a racemate. या फिर इसको ना racemic.
So is this A2?
Still, we'll probably start A2 in this class. Probably. Most likely, yes. But we have to, I think we have to cover alkanes and alkenes quickly. So I'll just go through that and then we'll. So I just went through optical isomers that you had enantiomers, and it's a mixture of enantiomers is known as the technical name for that is a racemate mixture. They're two non-superimposable mirror images. So, for example, if you have a molecule uh, that has a chiral carbon atom, so that molecule will have, for example, it's got four different groups. It's got CH2 and CH3 on this side, and it's got a CH3 group on this side, and it's got an OH group on this other side. Now this molecule will have it's a chiral center. It's got a chiral center, so it's going to have another version which is going to be a mirrored version of the same thing. So that mirrored version will also have a carbon atom. It will also have the same bonds, but these bonds are going to be mirrored. So this bond is over here. This is, and the dotted one is in this direction. So the H, and you've got CH3 on the other side. So I've got the OH, and I've got the CH2 CH3. Okay, so that's your other version. That's your mirrored version. So these are your two. So these are your two enantiomers. One is known as +1 or a clockwise one. The other one is known as a It's known as the other enantiomer, which is known as minus. The only difference between the two molecules is when you have optical isomers. Uh, the only difference is that they are, first thing, they're non-superimposable, just like your two hands. Okay, they look kind of the same, but they're not exactly the same. The other difference is that both enantiomers, they rotate plane polar. Both, I mean, that's the difference. So both enantiomers, they rotate plane polarized monochromatic light in opposite directions. So plane polarized monochromatic light in opposite directions.
सर ये आप एक्सटेंड कर सकते हैं?
बताता हूँ, ठीक है. एक, one of them is clockwise, the other one rotates it. So the other one rotates it anti-clockwise. So what this basically means is that light, polarization of light. Okay, that's kind of like this. It's this is, for example, in each wala balke. Like if you look at this image, this one specifically. Polarization is the vibration of the waves. If there's a wave coming in, okay, that wave, the particles could be vibrating up and down. They could be vibrating sideways as well. Now, most of the electromagnetic spectrum, for example, radio waves, which are reaching your phone, they're not polarized. I mean, the vibration is happening in pretty much randomly in all directions. Okay? I mean, normally you think of a wave as one polarization. I mean, that's what you've studied in physics as well. I mean, you know of waves like this, but waves are way more scattered. I mean, their polarization is like, it's everywhere. Okay? So, yeah, idea clear? What does polarization mean? Is that clear?
Yes, sir.
So most of the waves that are around you, they are unpolarized. Okay? जो आपके radio waves आ रही हैं, they are vibrating in random directions. But their filters, and those filters, what they do is they polarize the light. They kind of filter out all the other polarizations, like all the other directions of polarization, and the wave gets polarized in one direction. So that's plain polarized monochromatic light. Okay? The particles will be vibrating in exactly one direction. So that is polarization. Now, ये जो हम कह रहे हैं ना, enantiomers, what enantiomers do is that when light passes through them, the enantiomers, they kind of act as a filter, or I mean, they kind of transform the polarization. Like, for example, if this is, the particles are vibrating vertically, once they pass the solution, okay, once they pass through a solution that has an enantiomer, तो उनकी जो direction of polarization है, that changes. One of them rotates it clockwise, the other one rotates it anti-clockwise. For example, if the polarization is the blue one, then after passing through the mixture, जो enantiomer है, the polarization, the wave might rotate. Its plane of polarization might rotate. But is this idea clear?
सर
हाँ.
सर तो बेसिकली एनांशियोमर जो मतलब वो उसके परपेंडिकुलर आ रहा है ना पोलरॉइड के, तो उसको पास करने नहीं देगा ना?
नहीं, enantiomer is doing something else. ये तो diagram कुछ और है. अगर if I can, what enantiomer will do is कि it will rotate the polarization. इधर तो वो था ना कि this is a filter. I mean, it's a polarizer. ठीक है, वो तो cancel out कर देता है. It doesn't allow the other waves to pass through. ठीक है. You've got glasses, sunglasses होते हैं, which are polarized glasses, which exactly do the same thing. लेकिन that is something else. वो जो enantiomer वाली बात है ना, that is, forget this. ठीक है. What it does is, let's say you're getting a plain polarized monochromatic light, which is this one. If it passes through the racement mixture, तो उसकी जो direction of polarization है, that changes. Like if it's vertical, it will become horizontal. मतलब वो आइडिया क्लियर है?
Yes, sir.
तो एक सेकेंड, इफ आई कैन फाइंड, so it's something I guess like this. किधर गया है? हाँ, but this might be a good idea, but not really, I mean, that clearly explained, but uh so I guess ये वाला, that makes, so if you have an optically active sample, if you have an enantiomer, so if the particles are vibrating in this direction in the wave, the particles will start vibrating in a different direction. Okay, one of the optical isomer will rotate it in the clockwise direction, the other one will rotate it in the anti-clockwise direction. ये ज़्यादा clear है? Is this clear?
Yes, sir.
So, but yeah, I mean, you don't have to go into a lot of detail. You just have to understand that you'll have a solution which will have one enantiomer. You'll have a solution that will have the other enantiomer. One will rotate it clockwise, the other one will rotate it anti-clockwise. If you have both enantiomers, then the light polarization of light will not rotate. I mean, it will remain exactly the same because it's going to get cancelled out. ये अगर 20 degrees उसको rotate करता है towards the right, the other one will cancel that effect, and it will rotate it 20 degrees to the left. So if both enantiomers are present, then no rotation in the polarization will happen. ठीक है, बल्कि ये diagram ना इसको थोड़ा सा किधर गया diagram? अच्छा, ये वैसी, but otherwise you don't really have to go into detail about this. So अच्छा, next thing, so you'll be asked to identify optically active. There'll be a lot of questions identifying optically active isomers, molecules. So for example, if I have this molecule,
Sir,
let's,
could you please scroll up quickly?
इसका लिंक ले लो आप बोर्ड का, एक सेकेंड.
Thank you.
So you've sent the board link as well. So anyways, the next thing is just a couple of questions. Let's say I've got this. So I've so let's say I have this molecule and this is CH3. So this is CH3 and let's say I've got a Cl over here. How many chiral centers does this molecule have? So remember, 4 different molecule must be bonded to 4. The atom must be bonded to 4 different groups. So is this one chiral or not? कितने 4 different groups? I mean, it's supposed to have 4 different sides. So it's got 3 sides which are different. Like if you look at the 3 sides, all of them are different. There would be a 4th side. The H is not shown in chiral formula, so there must be another one. So there must be an H over here. Okay, so that this one is chiral. As a similarly, be clear enough.
Yes, sir.
As a similarly, the next one, that one will also be chiral because I mean, this side is different, this side is different, this side, bottom side looks different. Okay. So that is also chiral. There's going to be an H over here as well, ठीक है, which is not shown. तो एक H भी होगा, ठीक है, वो बल्कि एक बीच में वैसे लाइट सा शो कर देते हैं. There's going to be one H which is usually not shown. Achha, that's also chiral. Achha, this one is also going to be chiral because
7 chiral होंगे सर.
ठीक है, ये भी chiral है. अब वो गिन लेते हैं. This one will also be chiral, right? This one is not chiral because it's got two H's, right? This one is chiral. This one is also chiral. ठीक है, these are not chiral because two H's, two H's, two H's. So anything that's having two H's, so 3, 4, 7 ही हो गए. ठीक है. So there's going to be 7 chirals. Does anyone have any doubts about any of the chirals that I've marked? I mean, this is chiral because this side looks different. This side looks different. The bottom side looks different. Okay, so all 3 sides. And there's going to be a 4th hydrogen over here, which is not shown over here. Okay, so सारे different है. तो seem clear है ये? Rizwan, Siddha, Sana, is this clear?
अच्छा
हाँ.
सही है. शेयर वाले के साथ भी कर लूंगा.
कौन सा?
सर जो सीएल के साथ अटैच्ड है.
ये वाला? हाँ ना, तो इसकी सारी साइड्स डिफरेंट है ना. मतलब ये top different, right side is different. I mean, this side is, cyclic structure, but it is different. I mean, this thing, CH2, you don't have CH2 over here. You have something else over here. So uski jo right side hai, uski jo left side hai, that's different. Okay? And there's one H over here as well. So all 4 sides are different. So there's 7 chirals. Okay? Achha, about enantiomers, remember this, small enantiomers, they usually have exactly the same. Well, it's very hard to distinguish a small enantiomers. They usually have exactly the same chemical and physical properties. Achha, but when it comes to enantiomers, large biological molecules. So large biological molecules, because they're very shape dependent, which are shape specific, for example, enzymes, proteins, etc., where their function is very shape specific. They get affected very badly if you have stereoisomerism. So they will have drastically different functions. If the stereochemistry is affected. If any one of the chiral carbon atom you get that wrong, it's the entire structure or the shape of the molecule will change. ठीक है, मतलब आपका जो right hand है ना, if you right hand जो है, that fits in the right glove, right? If you get the stereochemistry wrong and instead you make a left hand, तो वो left hand will not be able to fit in the right glove, ठीक है? तो but large biological molecules which are shape specific will have drastically different functions if stereochemistry is even slightly changed. So आपकी body में ना, it's almost every molecule that's shape specific. Every amino acid that's chiral. So they will have different shapes. You'll have a right-handed shape, you'll have a left-handed shape, you'll have mirrored versions of a lot of molecules. You get one wrong, the whole structure will collapse and the whole structure will stop functioning. Okay? So biology, they're very sensitive to chirality. Small molecules where chirality is almost, hardly noticeable. Okay? So is this clear? क्लियर है सारों को? अच्छा, तो अब हम आगे मूव करें, ठीक है? We'll start with alkanes and alkenes. And अच्छा, before starting with alkanes and alkenes, naming naming तुमने quickly कर ली थी. अच्छा, before starting with alkanes and alkenes, I'll also talk about hybridization a little bit. ठीक है? Alkanes, briefly, what is alkanes? Alkanes are they're basically saturated hydrocarbons. Simple alkanes have a general formula which is CN H2N plus 2. Those are simple alkanes. Normally, the general formula doesn't really apply to complex molecules. All bonds are single bonds. So, for example, if you examples make it, you've got so if I have this molecule, so that's 2-methyl butane. So that's an alkane. ठीक है? Everyone knows what an alkane is. इसके ऊपर आ जाते हैं hybridization के ऊपर, ठीक है? Of an alkane. Hybridization is so when carbon makes no pi bonds, no double bonds, that's sp3 hybridization. ठीक है? So we're talking about sp3 when it comes to alkanes. The carbons are the carbons are sp3 hybridized. What happens is that carbon has 4 electrons in its outer shell. It's got a 2s1, a 2px1, it's got a 2py1, and it's got a 2pz1. So it's got these 4 electrons in its outer shell. ठीक है? 4 electrons है. And now carbon needs electrons in all of them. So carbon, when it makes sp3 hybridization, is when carbon makes no pi bonds. All of the bonds are basically your single bonds. And there is no pi bond or no double bond. So carbon को होगा क्या? Carbon will be bonded to 4 atoms. ठीक है? So what will happen is carbon's 4 electrons are going to be pulled by 4 different atoms. The 4 electrons are going to get attracted in 4 different directions by 4 different atoms, each one of them trying to gain those electrons. So carbon has 4 electrons. One electron in each one of these orbitals. And each one of these orbitals, they're getting pulled by, or pulled towards 4 different atoms. ठीक है? एक इलेक्ट्रॉन को ऊपर की तरफ पुल कर रहा है. Who are those atoms? There could be hydrogen atoms. ठीक है? There could be any atoms as long as carbon is making 4 bonds. So there might be a hydrogen atom that will be pulling that electron. There's going to be another hydrogen atom, another one, and another one. So basically, hybridization is that carbon had 4 electrons, but those 4 electrons and their shape, it changes. S was spherical. the electron was in a spherical region, but now it's no longer in a spherical region because it's getting pulled by this hydrogen atom over here. So the electron gets pulled towards this hydrogen. 2px had two lobes, but the electron got pulled by another hydrogen. So the shape of the orbitals, they change. So hybridization is simply that you start giving them new names instead of calling them 2s, 2px, 2py, and 2pz, because the shape has changed. You give them new names, which are, all of them are called sp3 hybridized orbitals. So it's basically the same electrons, but because the electrons are being pulled by different atoms in different directions, the electrons, the region in which the electrons exist, that shape of the region will change. Okay, is this clear? Bakio clear, Alicia, Haseeb, Rizwan, Umar clear? Sana, is this clear?
Yes, sir.
Yes, sir.
So you just start calling them new names, which are sp3 hybridized orbitals. If carbon was not bonding to any atom, then you had a 2s, 2px, 2py, and 2p. 2pz, carbon's electrons would be, so what does a p subshell look like? The p subshell looks
Dumbbell shape.
ये शक्ल है उसकी. ठीक है, the p subshell in reality looks like अच्छी शक्ल की तरह. एक सेकंड. So it's double shaped होता है, इस तरह होता है, ठीक है. I mean, that's how the electrons would actually, this is how the electrons would actually look like in a p subshell. But the electrons are getting pulled in different directions. So the electrons, they change their shape. If you superimpose all the p subshells, the p orbital, all the p orbitals together would look like this. Okay, but the electrons are getting pulled in 4 different directions. So they start looking like slightly different. Hybridization की जो definition है, that is it's the mixing of orbitals. The definition of hybridization is, if they are going to ask you that, so the technical definition is that it's the mixing of orbitals to form new bonding orbitals. To form new hybrid orbitals during bonding. The during bond formation. So that's sp3 hybridized, and so that's about it. Okay, just remember, carbon whenever all bonds are single bonds, it's going to be sp3 hybridized. Agla part here, okay, let's start with the reactions very quickly. You had just one reaction, which was free radical substitution. Okay. Free radical substitution will still be, they're going to ask you about free radical substitution. I said, remember, what's the purpose of free radical substitution? That it's that's how you get chlorine into the carbon chain.
Sir, halogen alkane stop कर दिए?
नहीं, अभी halogen alkane बनेगा ना, alkanes की free radical substitution है.
हाँ, तो सर like उसके related mechanism start किया ना अभी, मतलब वो nucleophile और सारे.
अभी उस पे नहीं है, अभी तुम उस पे free radical substitution पे. उसमें chlorine और bromine होता था plus UV light. Now remember, the purpose of this reaction was to substitute, this reaction will substitute chlorine or bromine into any carbon chain. not just alkanes, into any alkyl chain. ठीक है, remember, any alkyl chain. ठीक है, and the only problem with this reaction is that you can't really control it. You can't really predict what the output is. For example, if I have this so if I have this molecule, which is a carboxylic acid and a ketone, the purpose of the reaction is that it can substitute a Cl into any carbon chain. तो इसका अगर reaction होगा ना, I add, let's say, chlorine plus UV light. So what will happen is that I could get a number of molecules where the H's will be substituted by Cl. So this H might get substituted by Cl. तो यहाँ पे Cl आ गया. Or maybe multiple H's, this one, this one over here, they all get substituted by Cl. Now, one of the major byproduct is going to be HCl. So that's going to be your, so that's going to be the byproduct of the reaction. So you can't really predict how many H's will get substituted. So the number and the position of the H substituted of H atoms being substituted, that's kind of random. So as a result, you're going to get multiple products. So multiple products are going to be produced. So yeah, any H will get substituted in a carbon chain. It doesn't really matter it's an alkane or not, but any number of H will get substituted. So that's free radical substitution. It's going to happen with chlorine or bromine, and और उसका जो mechanism है, ठीक है? वो quickly कर लेते हैं. We'll just quickly do that. The mechanism of free radical substitution is that there are 3 steps. So you got 3 steps. The mechanism first one, initiation. What happens in initiation is, number 1, radicals are produced. Okay, second step, free radicals are produced. So for example, if you have Cl and a Cl molecule, it's got 2 electrons, and the electrons are going to be homolytically, they're going to split up. And you're going to get, you're going to get Cl radicals. Cl free radicals. What's a free radical? A free radical is a species. It's a very reactive species which has unpaired electrons. So with unpaired electrons, and they're usually very, very reactive. Now, the only reason this thing happens is because you've got UV light. Okay, that's why. In ultraviolet light, UV light के अंदर ना the molecule splits up. Okay, that's where they get the energy. That's so without light, this is not going to happen. UV light enables radicals to be produced, and then moving on to the second step. The second step is known as propagation. Now, in the propagation step, your radicals, they attack the alkane. Or they attack the hydrogen atoms. So if you have an alkane or any carbon chain which has got hydrogen atoms around it, the Cl radicals are extremely reactive. So a Cl radical will come in, and as it comes in, that Cl radical will try to attract electrons from this H. इस H को थोड़ा सा नीचे ले जाते हैं थोड़ा सा इसको. Achha, so what it will do is it will try to steal electrons because it's very electronegative. What the Cl will do is it's going to try and steal electrons from the H, and it will try to bond with it. And the carbon will take its electrons. It will kind of take its electrons back. So the product that is going to be formed in this case is going to be this, that you'll get. So that's your propagation step. So what you'll get is you'll get an HCl molecule. I mean, that's the first thing. So the H over here breaks off and combines with the Cl, and you get an HCl molecule, and that electron returns to carbon. So you got a propyl radical now. Okay, that's the. So this is what happens. Okay, next step is, okay, once this happens, the next step is the propyl radical will now go, and now that's a radical, that's a very reactive radical, and the carbon bonds are not complete. So that propyl radical will attack a Cl2 molecule. And it will try to bond with the Cl, and this electron will return back to this Cl. Okay, next step is the propyl radical will have its bonds complete. ठीक है, इनमें से एक जो Cl है ना वो जाके उसके साथ attach हो जाएगा with this carbon atom. And you got another, and this electron returns back to the Cl, so you got another Cl radical. And now what's going on is that the reaction will just continue. ठीक है, that's your propagation step. ठीक है, इसको खत्म ही कर लेते हैं. So it's just going to continue until all the Cls they get substituted. This अगला जो step होगा, it's going to be the same step repeated, except with one difference, and that difference is okay, one Cl has already been substituted. So there's one Cl already there. So the only difference is you'll have pretty much the same reaction, except at the start, one of the Cl is already there in सारों में. And now at the end, you get two Cls. मैंने ऊपर पता नहीं क्यों कर दिया, एक सेकेंड. अच्छा हमारे पास आ गया. So every time it's the same thing repeating over and over again. A Cl radical will come in, take away one of the hydrogens from anywhere, and that will leave it into a propyl radical. It will turn it into a propyl radical. The H will bond with Cl. It will form HCl, and then the radical will then go and borrow one of the Cls and bond with it. Another Cl radical gets produced. The same reaction now repeats, except for the fact that one of the Cl is already there. So at the end of the day, you'll get two CLs now. और फिर दोबारा रिपीट होगा. ठीक है. So it's going to, हाँ जी.
सर ये तब तक चलता रहेगा जब तक सारी जगह ऑक्यूपाई ना हो जाए ना.
हाँ. या फिर टर्मिनेशन ना हो जाए. ठीक है. So the last step is that your reaction might terminate at any point. ठीक है. That's your third step. So the third step is your termination. And in this step, what happens is that any of the free radicals that are forming can just combine with each other, and the reaction will stop. So free radicals will combine. So they're going to combine randomly. So any of the free radicals that you've drawn over here, for example, if I have this free radical, and I have even a free radical, so they can, I mean, these two can sort of join up. Now, for them to join up, what you have to do is you have to, like both carbon atoms, they've got, I mean, they're short of one bond, right? So both these carbon atoms can simply join up with each other. So this one will combine with this one. So what you'll get is you'll get a 6 carbon atom molecule. So that's 1, 2, 3, 4, 5, and 6. And ये जो दूसरा वाला है उसके पास end में यहाँ पे there's a Cl. The rest is all H atoms.
सर
हाँ जी.
सर इसमें से कोई भी दो रेडिकल्स मिल सकते हैं ना.
हाँ.
तो सर Cl और Cl मिल सकते हैं फिर.
हाँ लेकिन वो प्रॉपर मतलब वो फॉरवर्ड नहीं होगा, वो तो वापस आप उल्टा रिएक्शंस बना रहे हैं. हाँ लेकिन मिल सकते हैं. ठीक है. अच्छा so this one, any radicals, ठीक है. It's completely random. I mean this radical might combine with a Cl radical. ठीक है. For example, here's your Cl radical. So propagation step in the previous step. So any radicals that combine, they would just combine with each other. So these two might combine, and when they combine, they'll just form. What are they going to form? They're just going to form a chloroalkane. ठीक है. So all you're going to get is कि यहाँ पे ना Cl आ जाएगा. बात खत्म. So ठीक है. So this is free radical substitution. ठीक है. That's it. So termination, any of the radicals can combine together. Propagation, ठीक है, we did that. We devised that as well. और फिर end में ना you had initiation, propagation, termination. ठीक है. Clear है. Next time हम alkenes करेंगे और फिर we'll start with benzene. ठीक है. चले. Okay everyone. कोई question नहीं है? Question पूछ लेना. वरना you can leave. ठीक है. Love is.